Welcome everybody to Quadratic Functions and Equations lesson number 1. Today we are looking at connecting zeros, roots, and x-intercepts. So today I want to start with looking at functions and function notation. This is a review of grade 10. They have a nice little wordy definition of what a function is and what function notation is. So a functional relation or function is a special type of relation in which each element of the domain is related to exactly one element of the range. If any element of the domain is related to more than one element of the range, then the relation is not a function. So basically what they're saying is every input can only have one output. For each input can only have one output, or each x value can only have one y value. And you learned a bit of this in grade 10. We also look at function notation. So function notation is where we use this f of x notation here. So if we had an example of an equation that was y is equal to 2x plus 3, this is an equation in two variables here. We have an x and a y. Well, we could write that as function notation. We could say this is actually function f that depends on x, and it's 2x plus 3. So this is all just one thing, right? F of x. It's not f times x. It's saying this whole function right here is hang on. Shoot, there we go. This whole function here is function f, and that function depends on x. And this is called function notation. They like to use things like under the function, the image of 5 is 12. This is like super weird wording, and I try not to use the image wording too much. So let's scroll. I just want to show you. Okay, so here we have y is equal to 4x minus 8. That's an equation of the graph. Y is equal to 4x minus 8. We can write this in function notation by replacing the y with f of x. So it's the same thing. F of x is equal to 4x minus 8. So we just basically are representing that y with f of x. So that's saying the function depends on x. And then the next step here, they said, okay, well, if the input is 5, or if the x is 5, we put that in, and our output is 12. Our y value is 12. So when x is 5, when x equals 5, our y value is equal to 12. And that actually corresponds to a point on that graph. So if we were to write a point, we always write it as xy, and so that would become 5, 12, and you could graph that. The same thing is done in function notation, except where you see the x in the first iteration of that, you put f of 5. So you're actually saying that what's the function when the input is 5? Well, then you plug that 5 in, and you can say, and you get the 12, and you can say the function when the input is 5 is equal to 12. And that's the same thing, right? So it results in the same point. F of 5 is equal to 12. So that x represents the input right there. You can also do this. So again, here's the equation, y is equal to 4x minus 8. Here's the function notation. So I just want to move ahead now. There's a couple of things down here, but I think it's better off explained under this zeros of a function. So a zero of a function is the value of the independent variable. Normally in a yx situation, this is our x value. So a zero of a function is the value of x, which makes the value of the whole function equal to 0. Zeros of a function can be found by solving the equation f of x is equal to 0. So here it says find the 0. So that's a word that we're looking at, the 0 of the function f, where f of x is equal to 7x minus 21. So the 0 is going to be what value of x do we need in order to make this whole function equal 0? So what you can do to solve that is you can take your 7x minus 21 and set that equal to 0. And then you do your algebra, right? You want to solve for x. Solve the equation. Plus 21 to both sides. Minus 21 plus 21 cancels. You're left with 7x is equal to 21. And then divide 7 out of both sides. 7 over 7 cancels, and we're left with x is equal to 21 divided by 7 is 3. So the 0 of the function is 3. So that's the x value that makes the whole function equal to 0. That's the 0 of a function. We're going to skip investigation 1. I'm trying to keep these videos a little bit shorter. So we're going to go on to lesson 2, which I think actually covers everything from investigation 1 and goes into it a little bit deeper. So here we go. It says Jacques is determining the roots of the equation x squared minus x minus 6 is equal to 0. He wrote the equation in factored form and used the zero product law to determine the roots of the equation. So I think we did this in the factoring unit in the last lesson. So you can see here, this is our equation, x squared minus x minus 6. So we can factor that and then use the zero product law to determine the roots of the equation. So x squared minus x minus 6 equals 0. And so we are factoring using inspection because there's no a value. There's no constant in front of my x squared term. So now I'm looking for two numbers that multiply to -6 and add to -1. And that will give us x minus 3 and x plus 2. And then you remember that the zero product law says that this whole equation is 0 if this term equals 0, and the whole equation is 0 if this term equals 0. So if x minus 3 is equal to 0, and if x plus 2 is equal to 0. So then we can hopefully remember from lesson 7, I believe, in factoring, add 3 to both sides, x is equal to 3, and here subtract 2 to both sides, and x is equal to -2. So those are the roots. Those are the roots of the equation. And then if we look at B, it says the graph of y is equal to x squared minus x minus 6, which is the same expression or same equation that we had at the top, is shown. State the x-intercepts of the graph and mark them on the grid. So the x-intercepts are going to be where the graph crosses the x-axis. So the x-axis is here, or the x-axis goes all the way across. So where the line crosses is right here and right here. What values of x is that? Well, that's -1, -2, and 1, 2, 3. So the x-intercepts are at x is equal to -2 and x is equal to 3. And you can see that those intercepts are the same as these roots. So it says state the connection between the x-intercepts of the graph and the roots of the equation. Well, they are the same. Let's scroll up. Explain the connection between the factors and the roots. So the values, we can say the values of x, which make the factors 0, are the same as the roots. And then it says down here, consider the function g of x is equal to x squared minus x minus 6. Determine the zeros of the function. So we know when we're looking for zeros of the function, we're looking for the x value that makes this whole equation equal to 0. So you can say x squared minus x minus 6 is equal to 0. And then what we're going to do is we're going to factor this. And this is going to look very similar to what we just did at the top, right? We already solved this equation to be x minus 3x plus 2. And then the zeros are going to be the values that of x that are going to make this equation 0. And we know that already is going to be plus 3 and minus 2. So it says here, state the connection between the x-intercepts, the roots, and the zeros. So these are all the same. You're talking about the same things if you're talking about the x-intercepts, the roots, or the zeros. And I think that's the whole point of this lesson is that the x-intercepts, the roots, and the zeros, you're talking about the same thing. They're all the same. Fill in the blanks in the following statement regarding the function with equation y is equal to f of x. So the zeros of the function, the x-intercepts of the graph of the function, and the roots of the corresponding equation y is equal to 0 are the same numbers. So here's the graph that we did yesterday in the last page. The graph that we did on the last page has the x-intercepts of -2 and +3, and a y-intercept of 6, -6, sorry, at the bottom, below. That's just an equal sign, -6. The function f of x is equal to x squared minus x minus 6 has the zeros -2 and 3, and the equation has the roots of -2 and 3. So you can see they're all the same. I'm trying to just reiterate that. I'm going to skip the graphing calculator thing, and we're going to finding zeros of a function. So to find zeros of a function, you can either substitute 0 in for f of x and find the roots, or graph the function and find the x-intercepts. We're going to do a pretty big focus on, if it'll let me use my pen, there we go. We're going to do a pretty big focus on this one, finding the roots by factoring. So let's look at this. Let's do some factoring. So if we have the first equation here, x squared plus 8x is equal to 33. The first thing you want to do is, well, we want this equation to equal 0. So we can subtract 33 to both sides. And then what we're left with is x squared plus 8x minus 33 is equal to 0. And then you can see that this is a trinomial with no coefficient in front of the x squared term, so we can factor this by inspection. So we're looking for two numbers that multiply to -33 and add to +8. So I'm just going to come up to the side here and do my little 1 times 33, 3 times 11. I think that's the only ones. It has to be negative, so it can be plus. We're trying to add to +8, so a -3 and a +11 get me to +8. So x plus 11, x minus 3. And the values that make that equation 0 are going to be, well, x plus 11, so -11, and x minus 3, so +3. The opposites there. You change the sign and you're good to go. Maybe I'll use this opportunity to show you a trick here. So in the next one, it's already factored for us. 6 multiplied by 4x plus 5 multiplied by x minus 3 is equal to 0. So we know one of the zeros, or one of the roots, is going to be +3. But now we want to deal with this one. So normally we would say, okay, well, 4x plus 5 is equal to 0. Then we're going to do the algebra. So -5 minus 5 we're left with 4x is equal to -5, and then divide 4, and then x is -5 over 4. But there's a, hang on. There's a quicker way to do this. So if 4x plus 5 is one of your roots, or one of your factors, sorry, to find the root, you're going to take the, so you can say x is equal to, change the sign of the last one. So instead of +5, we have -5, and divide by the first number. And that'll work every time. And you can check that by plugging the x back into that, where you see that x in the equation, and see if it equals 0. And you can see that they're the same there. So if one of your factors, for example, was 2x minus 3, well, the root of that is going to be, change the sign of the second one, +3, divide by the first one. Hopefully that makes sense. I'm going to erase this because I actually do want to do question C. Let's erase that and erase that. In C, you can have a look here. It's a binomial. We can check for perfect squares, but it's not. So the next thing we want to do, or the first thing we should have done actually, is factor out the greatest common factor. So we can pull a 2 out, and we're left with x squared minus 4. And then you can see that this is a difference of perfect squares. So now we can rewrite that as the two values that multiply to get x squared is x times x, and the two values that multiply to get 4 is 2 times 2. One's a plus, one's a negative. So now we have this in factored form, 2 multiplied by x plus 2 multiplied by x minus 2. And our roots are going to be x is equal to 2 and -2. Cool. For the following functions, find the zeros and find the y-intercept of the function. Well, we can find the zeros. It's the same as finding the roots. We're going to take our function here and set it equal to 0. 5x squared plus 15x minus 20 is equal to 0. In this case, I can factor a 5 out. So I'm left with x squared plus 3x minus 4. And now I have a trinomial with no constant in front of the x squared, so I can factor that with inspection. So two numbers that multiply to -4 and add to +3. So we can say multiplying to -4, -1 and 4, 1 and -4. And the one that adds to +3 is right here, -1 and 4. So you have x minus 1, x plus 4. And that makes the zeros are x is equal to 1 and -4. And now we want to find the y-intercept of the graph. So you have to remember, when you're finding the y-intercept, what's the value of x? Anywhere you cross the y-axis on the graph, your x value is always 0. So what you can do is you can solve your function when x is 0. So you can say f of 0 is equal to 5 times 0 squared plus 15 times 0 minus 20. And when you solve this, this term is 0, this term is 0, so they both go away, and you're left with f of 0 is equal to -20. So it means your y-intercept is -20. Let's do the next one here. We have 3x squared minus 11x plus 10. So for finding the zeros, we are going to set that equal to 0. And now we want to factor that. So I'm going to go 3 multiplied by 10 gets me 30. So now I'm looking for two numbers that multiply to 30 and add to, I just covered all of it, add to negative 11. So if you want, you can do that off to the side somewhere. 30 is going to be 1 times 30, 2 times 15, 3 times 10, 5 times 6. Well, negative 5 times negative 6 gets positive 30, and negative 5 plus negative 6 is negative 11. So now I can split this term. We're doing our decomposition here. 3x squared minus 6x minus 5x plus 10 is equal to 0. Now we can group and factor. So the largest common factor I can pull out of the first one is going to be 3x, and then I'm left with x minus 2. And in the second one, I can pull out a negative 5, and I have x minus 2. And then if I factor that out, I have x minus 2 and 3x minus 5 is equal to 0. So now my roots are going to be positive 2 and positive 5 over 3. And if we look for the y-intercept, if you go back to our function up here, you can see that if x is 0, that term goes away. If x is also 0, that term goes away, and all we're left with is a positive 10. So our f of 0 is going to equal 10. Therefore, our y-intercept is 10. Okay, I want to go over one more example here. Almost done. So we have g of x is equal to 2x multiplied by 2x plus 1. So what we want to do is set that equal to 0. And we don't really have to do any factoring here. We know that one of our roots is going to come from this. So that's going to be negative 1 over 2. And one of our roots is going to come from that constant. So in this case, if x is 0, the whole equation is 0 because 2 times 0 times anything in those brackets is going to be 0. So your roots are 0 and negative 1/2. And our y-intercept, a little bit harder to figure out this time. So we're looking at the function when x is 0. So now we're going to get 2 times 0 times 2 times 0 plus 1. So basically anywhere I have an x value in this equation, I've put 0 in here and here. And you can see that because this x is on the outside, or right there, that we're multiplying the whole term by 0. So that means, I don't know why that won't stay, g of 0 is just going to be 0. So our y-intercept is 0. Cool, that's it for lesson 1. We are just kind of prepping ourselves to get ready for some graphing and looking at parabolas. So try to get this dialed in so that the rest of the unit is a little bit nicer. Thanks for watching. Don't forget to like and subscribe.